Our planet is a place of breathtaking beauty, but it also holds immense power. A force that can build mountains and carve canyons, but also a force that can unleash unimaginable destruction. Hurricanes that tear cities apart, volcanoes that reshape landscapes, earthquakes that shatter the very ground beneath our feet, and tsunamis that swallow coastlines whole. For all of human history, we have been at the mercy of these colossal events. But today, the story is changing. This is the story of a new kind of battle, one fought not with weapons, but with knowledge. It's humanity versus the storm, science against the seismic shock, innovation against the incoming wave. In labs and research stations across the globe, a quiet but relentless war is being waged. Here, the heroes are scientists, engineers, and researchers. They are the frontline defenders in our struggle to understand and survive the planet's most violent tantrums. Their mission? To peer into the heart of the chaos, to decode the secrets of these natural phenomena, and to turn that knowledge into a shield for all of humanity. While nature unleashes its fury, these brilliant minds are piecing together the puzzle, one data point, one equation, one breakthrough at a time. This isn't just an academic exercise. It's a race against time where every discovery can mean the difference between life and death. So, how do we fight an enemy we can't see coming? The answer lies in the science of prediction. From thousands of miles above, satellites watch over us, their unblinking eyes tracking the birth of a hurricane. They measure wind speeds, ocean temperatures, and atmospheric pressure, feeding this critical data into supercomputers. These digital brains then run complex simulations, forecasting the storm's path and intensity with increasing accuracy, giving communities days, not hours, to prepare. On the ground, a network of seismographs listens to the faint whispers of the earth. These incredibly sensitive instruments record every tremor, every rumble, helping scientists map fault lines and understand the strain building up in the planet's crust. For tsunamis, a system of deep ocean buoys can detect the telltale pressure changes from an undersea earthquake, sending out an alert that races across the ocean faster than the wave itself. But not all disasters play by the rules. While we've become proficient at forecasting hurricanes and tsunamis, the holy grail of prediction, knowing exactly when and where a major earthquake will strike, remains just beyond our grasp. The Earth still holds some of its deadliest secrets close. Let's zoom in on the anatomy of a disaster. Take hurricanes, for instance. These massive, swirling storms are essentially heat engines, born over warm tropical waters. Scientists fly specially equipped aircraft directly into the eye of the storm, a terrifying but necessary journey to gather first-hand data. This information helps them understand the storm's internal structure and what makes it intensify. Armed with this knowledge, engineers design better defenses. They create building codes that demand stronger roofs, impact-resistant windows, and foundations that can withstand furious winds and storm surges. Coastal communities are now building higher seawalls and restoring natural barriers, like mangrove forests and wetlands, which act as nature's own speed bumps against the incoming water. It is a constant cycle of learning from the last storm to better prepare for the next one. Now, let's talk about earthquakes. Unlike a hurricane we can see forming, an earthquake is a sudden, violent release of energy that has been building up along a fault line for years, even centuries. Seismologists study the history of past earthquakes and use GPS to measure the slow, steady creep of tectonic plates. This helps them identify areas of high risk and estimate the probability of a quake happening over a period of decades. But predicting the exact day is still science fiction. So, if we can't predict them, how do we survive them? The answer is engineering. In cities like Tokyo and San Francisco, skylines are a testament to human ingenuity. Buildings are designed to sway, not break. They sit on massive rubber and steel shock absorbers called base isolators that allow the ground to shake while the structure above remains relatively stable. Flexible joints and reinforced steel skeletons help dissipate the seismic energy. These aren't just buildings. They are sophisticated machines designed to ride out the Earth's fury and protect the people inside. Then there's the silent threat that follows an earthquake, the tsunami. When a massive quake occurs under the ocean, it can displace a colossal volume of water, creating a series of waves that travel across entire oceans at the speed of a jetliner. When these waves reach shallow coastal waters, they slow down and grow to terrifying heights. To combat this, scientists have developed sophisticated warning systems. The moment an undersea quake is detected, computer models simulate the potential tsunami, predicting its size in rival time for coastlines thousands of miles away. This can provide precious hours of warning. On the engineering front, countries like Japan have invested in massive tsunami walls, some towering over 40 feet high. They've also designed vertical evacuation shelters strong, tall buildings where people can quickly get above the reach of the waves. It's a two-pronged approach: warn them it's coming, and give them a safe place to go. And what about the fiery mountains? Volcanoes give us more warning signs than earthquakes do. Magma moving beneath the surface causes small tremors, changes the ground's shape, and releases gases like sulfur dioxide. Scientists use a whole toolkit to monitor these changes. Altimeters and GPS measure the ground swelling as magma pushes up from below. Gas sensors sniff the air for volcanic fumes. Seismographs listen for the unique signature of magma-induced earthquakes. By putting all these clues together, volcanologists can often forecast an eruption with enough lead time to evacuate nearby populations. For communities living in the shadow of a volcano, this science isn't abstract, it's a lifeline. Engineers have also developed methods to divert slow-moving lava flows using earthen barriers, or even by spraying them with massive amounts of water to cool and solidify the leading edge, a tactic famously used in Iceland. The battle against natural disasters is far from over. Nature will always be unpredictable, and it will always test the limits of our knowledge and our resolve. But we are no longer helpless bystanders. Science has given us the tools to see, to understand, and to prepare. From the ruins of a disaster, we see communities rising again, not just rebuilding what was lost, but building back smarter, stronger, and more resilient than before. This progress is a testament to the human spirit. The future of our safety relies on continued investment in research, on the courage of scientists who chase storms and climb volcanoes, and on global cooperation. Because when a hurricane forms or the ground begins to shake, we are all inhabitants of the same small, fragile planet. The knowledge we gain in one part of the world can save lives in another. The fight continues, and with every new discovery, we write a more hopeful chapter in the story of humanity's survival. Thank you for watching, and if you found this journey into the science of survival as fascinating as we do, please consider subscribing for more content. Stay curious and stay safe.